Section 3 of Chapter 6 is about electronegativity and using this to determine bond type. So the first question is, what is electronegativity? Electronegativity is a measurement of the ability of an atom or an element to attract electrons. So how capable is a specific atom or element of able to attract or gain electrons? So we have periodic tables, and then we can add information to periodic tables to show other trends or information. So if you look at this image at the top, it looks like the periodic table. It's set up the same, except now instead of atomic masses in the bottom of each block, we actually have electronegativity numbers. And there's a copy of this for you to use. So you don't need to look up on the internet. I have provided one for you in the files. So when you're doing electronegativity calculations, as I said, you need to be looking at a periodic table that has the electronegativity values on it, not just a normal periodic table. And you're going to be looking at these numbers that are usually rounded to 2 decimals. So how do we determine electronegativity between two atoms? You take the electronegativity values given to you on the chart and you simply subtract. It's always the larger electronegativity value minus the smaller electronegativity value, and that gives you a difference. Be aware that as this number, the difference increases, so does the bond strength. So the bigger the difference is, the stronger the bond. Covalent bonds are weaker than ionic. So when you're looking at that number you solve for, if it is greater than or equal to 1.67, we classify it as ionic. If it's less than 1.67, we classify it as covalent. However, we should know by this point there are 2 types of covalent bonds. So taking this chart and breaking it down even further, we can say that once again, greater than or equal to 1.67, a difference of that will be an ionic bond. Anything less than that will be covalent, but we can specifically say between 0.00 and 0.4, it will be nonpolar covalent. From 0.41 up to 1.66, it is polar covalent. So let's actually do some problems and determine how this works. So you need your electronegativity chart either put up on your screen or printed. It says determine the difference in electronegativity, which you can abbreviate capital E, capital N, since it's a long word, between 2 atoms, in this case nitrogen and hydrogen. And once you've determined the difference, you want to determine the bond type. So the first question is, what is the electronegativity value for each of these? So I'm going to consult my electronegativity periodic table, not just the regular one. So looking at that table, nitrogen's electronegativity value is 2.81, and hydrogen's electronegativity value is 2.20. So to determine the difference, I take the bigger number, I subtract the smaller number, and I find the difference. You can never have a negative number. It's always the big number minus the small number. So doing this math, I get a value of 0.61. So that is my difference in electronegativity. If I take that number and refer back to this chart, where does it fit in? Well, 0.61 falls in between this, so we're going to say it's polar covalent. So this is the difference, and then it's polar covalent. So I've determined the difference in electronegativity, and I've determined the type of bond present. So it's not hard math, you just have to know how to use the chart. Okay, another question. Try this, pause the video, try it yourself. So we're determining the difference between potassium and chlorine and then the type of bond. Potassium is K, chlorine is Cl. So looking at my periodic table, K, potassium, has an electronegativity value of 0.84, and chlorine has a value of 3. So I take 3 minus 0.84. I get a value of 2.16. That is the difference in electronegativity. Then I'm going to refer back to this chart. If it's greater than 1.67, which it is, we have an ionic bond. So the difference is 2.16, and it is an ionic bond. I'm determining the difference in electronegativity and using that number to determine the bond type. All right, try another. Lithium versus fluorine. So lithium is Li, fluorine is just capital F. Lithium's electronegativity value is 0.96. Fluorine has the highest electronegativity value of 4. 4 minus 0.96 is 3.04. So we have a difference of 3.04. Anything greater than 1.67 is ionic. So once again, you have to know the element symbol, consult the electronegativity table, find its values, correctly subtract, and then consult the chart. Okay, last one. Compare chlorine and bromine. So chlorine is Cl, bromine is Br. Chlorine's value is once again 3. Bromine's value is 2.82. So if I subtract, I get 0.18. I'm going to go back to that chart again. 0.18 falls in this category, which makes it nonpolar covalent. Okay, so that is section 3. Determining electronegativity and using it to find a bond type.